Good morning all. So what did we discuss in the last class? Shrikant sir were telling, we'll have a quick recap of what did we do in the last class, continuing some theory part of it for 10 minutes, and then we'll have our practical session today. Okay. So we'll start building our first ANN model from scratch today in the class once I'm done with explaining some theoretical concepts which were pending in the last session. So we have started with basics of neural networks, right? Yes or no? So what did we see in the last class? We have seen what is a perceptron. What is a perceptron? A simple single layer neural network, or a simple neuron is called as what? Perceptron, right? And we have seen the structure of artificial neural network. Okay. So how does artificial neural networks looks like? Yes? Is this a simple neural network? Yes or no? So it consists of how many layers? 3. What are they? Input layer, hidden layer, output layer. If we have more hidden layers, we call that network as multi-layer perceptron or what? Deep neural network or artificial neural network. Okay. So when we talk about this, we have seen a simple neural network consists of input layer, hidden layer, and then output layer. Okay. Now when I want to process my input through artificial neural network, okay, how do I do that? How does ANN work? Yes? We take the input and give the input to the input layer, and from the input layer we pass the input to the hidden layers by adding what? By multiplying the input neurons with weights and adding a bias term to it, right? So if depending upon how many neurons we have in the input side, we take the summation of xi into wi. What is xi? The input neurons. Okay. What is wi? The random weights that we are assigning to our input neurons. Okay. So we sum all the product terms of xi and wi and we add a simple bias term to it. Okay. So we have seen what is the importance of weights and biases also in the last class. Okay. So once I am done with multiplying xi, wi and adding a bias term, I give it to an activation function, right? So what is the role of activation function? It adds some non-linearity to the data and it is used for helping us or determining the neuron which has to be activated, which actually contains the information which will be produced at the output. Okay. So as you can see here in the figure, we have x1 to xn, which are the input nodes. We multiply x1 to xn with the weights, okay, and then add a bias term to it and find the summation and then give that to an activation function and then we produce the output. Okay. And this process is called as what? Forward propagation. Okay. So as told you in the earlier class, we have 3 steps when we deal with artificial neural networks. The first step is what? Forward propagation, wherein we multiply xi, wi plus b and apply it to the activation function. Okay. Now once I am done with forward propagation, what is step 2? Error calculation. Okay. How do we calculate the error? Error is usually calculated by what? Actual value minus predicted value. Okay. More the deviation in the predicted values, more the error is. Okay. So if I get only 20% accuracy or if the error is large, what do I do in step 3? We go for backward propagation, right? So what is backward propagation? Changing the weights. Okay, we randomly change the weights and do the forward propagation again. So this is an iterative process. Okay, so first we do forward propagation, calculate loss. If the loss is not as desired, if the loss is more or if the accuracy is not as desired, we go with backward propagation, right? So in the last class we have seen different activation functions as well. So what are the 4 activation functions we have studied? Sigmoid, tanh, ReLU, softmax. Why do we use sigmoid? For binary classification task we use sigmoid. Why do we use tanh and ReLU? In the hidden layers. For the hidden layers we either use tanh or ReLU, but we prefer using ReLU. Okay. In the output layer we use which function? Softmax. Okay. So these were the 4 activation functions that we have discussed in the last class. So we have also looked into loss function calculation or cost function calculation. Okay. So this is different for regression and this is different for classification task. Okay. What do you mean by regression task and what do you mean by classification task? When we deal with continuous values as the target variable or output variable, the problem statement is defined to be a regression task. For example, predicting the current temperature. Okay, if I say what is the current temperature, we say 27 degrees, 28 degrees. So when you have your output as continuous values, we call that as a regression task. When we have output as a categorical variable, for example, whether a person has fever or not, whether you will pass the exam or not. So what is the possibility of the answer? Yes or no, true or false. Okay. So when you have this kind of output variables, categorical output variables, we use classification task. Okay. So the loss function that we take depends upon what? Depends upon the problem statement. Okay. If suppose you are working on leaf disease detection. Okay. So what are the 2 possible outcomes we have for this? The diseased leaf or non-diseased leaf. So in this case we go for classification because I have only 2 possible outputs. Okay. So what is the loss function that we use for classification? What is the loss function we use for classification? Huh? MSE is for regression. For regression we use MSE, mean square error. Okay. For classification it is categorical cross entropy. Okay. Binary cross entropy for binary classification task. If you have multi-class labels in the output, we go for categorical cross entropy. Okay. So this is what we have seen in the last class, right? So we have seen what is forward propagation, how forward propagation happens, and then we have seen activation functions. After forward propagation we go for calculating your loss. We have loss function separately for regression, we have loss function separately for classification. Okay. So today I will complete this process by explaining you the backward propagation and then we will start with our hands-on session. Okay. Yeah. So for those who are absent, this is a quick recap. So what do we do in step 1? We take the input neurons x1 to xn and then multiply them with what? Weights, and pass the inputs along with the weights to the next layer, which is hidden layer. Okay. So as you can see, if x1 to xn are the input layers, we pass them to the hidden layers. Okay. Now after passing all the inputs, the actual computation happens in the hidden layers. Okay. So this is how the hidden layer functionality takes place. Okay. So what is Z1? Please look at the term Z1. Z1 is nothing but the input that I am giving to the hidden layer. Okay. So what does hidden layer takes here? W1 into L1. Okay. So L1 is nothing but the x1 that I am taking and W1 is the weight that I am adding. Okay. So if I have 10 input neurons in the input layer, I have x1 to x10. If I have 20 inputs in the neuron first input layer, I have x1 to x20, which are multiplied with weights. Okay. Now who will give us weights? Random. Okay. We will see in the code how are the weights generated. Okay. And then after I do this, I add a bias term at the end. Okay. So what is Z1 here? Z1 is nothing but the input which is given to the hidden layer, which is nothing but xi wi plus b, summation of xi wi plus b. Okay. Now once I am done with this, I will apply activation function to Z1. What do I do? I apply my activation function to Z1. So this is what happens in the hidden layers. Okay. So I am taking xi, multiplying with random weights wi, summation of all xi and wi, and I am adding a bias term to that. Okay. So this is the entire computation operation that takes place in the hidden layers. Okay. Now once I am done with that, we will go for the last layer, which is nothing but the output layer. Okay. So once I go to the output layer, we start calculating the error. Okay. So what is error? Actual value minus predicted value. If the actual value is 9 and my predicted value is 5, so the error would be 9 minus 5. Okay. So more the error, less the accuracy. Less the error, more the accuracy. Okay. Now, if suppose the accuracy is not as expected, we'll go with what? Backward propagation. Okay. Now, let's see those 3 steps. So, what am I doing in the forward propagation? Multiplying inputs by weights, adding biases, and applying an activation function. Okay. So, what am I doing in what am I doing after I am done with forward propagation? I am estimating the error or calculating the loss function. So, you can note this. For regression task, we use what? Mean square error. I explained you in detail in the last class. Why is it mean square error? What does that mean? Okay. And then for classification task, we use what? Cross entropy. Okay. If you have only 2 labels, yes or no, true or false, we go for binary cross entropy. If you have multiple class, if it is a car, bike or lorry or auto, whatever it is, okay, if you have multiple classes in the output, we go for categorical cross entropy. In general, we say for classification it is cross entropy. Okay. Now, this is how we calculate your loss function. Okay. So, once I am done with loss function, we will go with what? Backward propagation. Are you all okay with this now? Yes or no? As you can see here in the figure, working of ANN is a 3-step process. Forward propagation, error calculation and backward propagation. Now, let us see backward propagation. Okay. Now, what do we do in backward propagation as I told you? Now, I have done with forward propagation, I am done with that, I calculated error, I am not satisfied with the output here, so I go for backward propagation. So, look at the first point there. So, what am I doing in backward propagation? Backward propagation is nothing but the process of what? Updating. The process of updating weights and biases on the error of the network's prediction. So, when I say backward propagation, I go from right to left. Forward propagation from input to output. Backward propagation takes place from output layer. Depending upon error, I adjust my weights such that my error may be either reduced or increased depending on how you change your weights. Okay. Now, how many times do I have to do this? Depends upon the model. Till we get good accuracy, till the error is reduced, you are supposed to repeat the process of what? Adjusting the weights. Go for forward propagation, calculate error. If your error is still high, go for backward propagation again and so on. Is it clear? So, backward propagation takes place in 2 important steps. Okay. So, what is step 1? Computing the gradient of the loss function with respect to each weight. I am adding some weights, right? So, with respect to each weight, we will calculate the gradient. So, in the first class, I asked you to study chain rule and come. Okay. So, if you doesn't know the chains rule, you will not understand how do we calculate the loss in the backward propagation and how are the gradients working. Okay. Yeah. So, we will adjust the weights and biases and try to minimize the loss function. Next slide. Yeah. So, how does backward propagation works? How does it work? It works by updating what? Weights and biases and finding the optimal values of weights. Finding what? Optimal values of weights such that my loss function would be reduced. Okay. Now, how the weights are updated and the new weights are calculated. So, madam, as you said, when I do my forward propagation, random weights are assigned. But how are the weights changed? Okay. So, when I go for backward propagation, the one question that rises is, how are the weights getting updated or how are the weights getting changed or how are new weights being calculated? Okay, the answer is this. What is that? We use optimizers. We have different activation functions, we have different optimizers which will actually help us in updating the weights with which I can reduce my loss function. Okay. So, we look into different types of optimizers, applying them. Once we proceed, we will just use gradient descent, a simple optimization algorithm for the initial classes. Okay. So, I repeat, we have so many different types of optimizers which will actually help us in updating these weights or changing the new weights in backward propagation. But for now, for the initial sessions, we will be using the basic optimizer which is called as gradient descent optimization algorithm. Okay. Now, let's look into what is gradient descent algorithm, which we apply for adjusting the weights in the backward propagation process. Okay, yeah. So what is gradient descent? Gradient descent is nothing but one of the optimizers which helps us in calculating new weights. Are you all okay with what is gradient descent? The most important concept in machine learning or deep learning or in AI. Okay. So what is gradient descent? It is a optimizer. It is an optimization algorithm which will help us in what? Adjusting weights in the backward propagation process. Okay. So as you can see here in the image, the curve is our cost function. What is the curve? Cost function. Cost function is nothing but the loss function. Okay. So if you take, if I suppose I have 10 samples, the difference between the predicted value and actual value of one sample is called as loss function. But when I take a data set, I have to consider all 10 samples, right? So the average of those 10 samples is called as cost. Okay. Loss is for one sample, cost is for all samples. Okay. So the image that you see here, the curve especially is the loss function curve. Okay. So what is our main aim here? To minimize the error by applying what? Gradient descent algorithm. Okay. So we use that global minima. Global minima is nothing but the minimum value that I can take by adjusting the weight such that my error would be gradually reduced. Okay. So we'll talk in depth when we talk about optimizers. Okay. Madam, change slide. Okay. Now, how do we get this global minima? How does gradient descent algorithm work such that the weights it assigns will produce us the low cost function? Okay. So when you look at this, first the weights are initialized randomly. That we all of us know, right? Using rand function from NumPy, we assign the weights randomly. Okay. Now, after we do that, we calculate the error and then we calculate the gradient for each weight that we are updating. Please remember this, derivative of loss with respect to weight. Please remember this point. So what do we do in gradient descent? We calculate derivative of loss with respect to each weight, that is dou L by dou W. Dou L is nothing but the loss, dou W is nothing but the weights. Okay. So the new weights are calculated using this formula. Okay. So Wx is nothing but the new weight that I want to calculate, and that I calculate with respect to the weights assigned minus A is a learning rate. Okay. I add one parameter called what? Learning rate, which is multiplied with dou of error by dou of W. First I will understand what is the error with respect to the weight. I multiply that with a small parameter which is called as learning rate and then try to adjust my new weight. Is that clear everybody? So how are new weights calculated? New weights are calculated by first finding the derivative of loss with respect to weight, multiplying that with the learning rate, and then we go for this particular thing. Okay. So this is how, depending on first weight, what is the error, dou of loss with respect to that weight, and then I calculate my new weight. So this is how your gradient descent algorithm works. Okay. So this process of calculating new weights, then errors from the new weights, and then updation of the weights continues till we get global minima or the loss function is gradually reduced. Okay. So let's start working on building ANN from scratch. So are you all ready? So 3-step process basically. So we'll have so many other steps in between, but basically if you want to work with developing an ANN model or neural network model from scratch, okay, so we have to understand 3 important steps. What is step 1? Forward propagation. Step 2, error calculation. Step 3, backward propagation. Is that clear? In forward, summation of xi wi plus b, error calculation, actual minus predicted. For regression we go for MSE, for classification we go for cross entropy, and then backward propagation where we use gradient descent by updating the weights, changing them, go for forward, calculate loss function. So this is a iterative process. Okay. So before we start with hands-on, we will use the tantric is not yet ready. So for today, for this session, we will use Google Colab notebook. Okay, so we'll do it simultaneously along with you guys. All of you please open your laptops. Okay, and before you do that, let me tell you one thing. So we are working on classification task today. Okay, so I'll send you one data set which is on breast cancer prediction. Okay, so can I treat this breast cancer as classification task? Yes. Why? Breast cancer will have only two possible outputs. Whether, depending upon the input features, I say whether the person has breast cancer or no. Okay. So for this reason I say this is a classification task. Okay. Now in your WhatsApp group we will send you the CSV file. Okay. What is CSV file? Comma separated value file, which is the data set. Okay. So we will send you the breast cancer data set. We will go with all step-by-step explanation. Along with us, we request you to do it simultaneously. Okay, you can sit and work on it. Okay. Data set group lo pedam. What do you do with the data set? Okay, please download that data set. Okay, so now we'll show you how to work on Google Colab environment. Okay, and type Google Colab. Okay, how many of you have already worked on Google Colab? Okay, very few. Okay, not a problem, we'll explain it from the beginning. So go to Google and just type Google Colab. Internet open check. So are you all ready? See, we require 1 hour at least to complete the exercise. So we should be fast.
If you have your inbuilt editor also, look fine. Jupyter or Spider, just open up and try, get it done.
Okay, so open the first code cell. Okay, so take your book and pen and write down each steps. Okay, or you can type it there as well. Okay, so step 1 is we import the libraries. So we'll see what all libraries we need to work on ANN model first. Okay. Step 1.
Yeah, sir, can you zoom a little bit?
Yeah, yes, sir. The text cell lo rasesai, the comment bettesai.
Yeah.
Step 1 for developing any machine learning or deep learning model is first we have to import libraries. Okay. So do we require NumPy? Do we require NumPy here? Yes. Why? Because we have to calculate derivatives and then randomly generate weights. So we import NumPy as NP. Okay. Please do that. Import NumPy as NP. Do we need pandas here? How do you read the dataset without pandas? For reading the CSV file we require pandas, right? So import pandas as PD. Import NumPy as NP, import pandas as PD. These are the two important libraries which we need. Okay. First we import NumPy and then import pandas. NumPy, import pandas, and then what are the other libraries we need here? Matplotlib if you go for any visualization. For now we will not do anything. Okay. So we will just develop a simple neural network by forward propagation, error calculation and backward propagation. So Matplotlib is not required. Okay. Now after that we require sklearn library, scikit-learn library, because listen to me first. All of you stop working on this and listen to me. So we have this operation of dividing the data set into training data and test data, right? I told you in the first class. What is training data? What is test data? If suppose I have 100 samples, I divide these 100 samples into two different categories. One is called training data with which I train the model. Test data with which I test the model and check if my model is working properly or not. Okay. Now this train test split function is available in sklearn library. Okay. Now apart from this, I also have to do some pre-processing of the data set, right? Yes or no? So for which I use some pre-processing steps. So here for this particular data set we require standard scalar. I'll explain you what is standard scalar, why do we need that. So from sklearn.preprocessing, please import standard scalar. I'll explain you what is standard scalar once we proceed. Import numpy, import pandas. From sklearn.preprocessing, import standard scalar. And then from sklearn.model selection, import train underscore test underscore split. Now this function train test split is used for splitting the data into training data and test data. Did you all finish this? Did you all import these 4 libraries? Yes or no? Import numpy as np, import pandas as pd. From sklearn import standard scalar, from sklearn.preprocessing, and then from sklearn.model selection import train test split. Okay, now this is step 1. Okay, next step 2 will load the data set. I've already shared you that CSV file, right? So we'll see. First, if you're working on Google Colab environment, you have to upload the data set into the environment. Okay. See, pre-processing is a module, standard scalar is a function. From that module of sklearn library, I am importing that function. Okay. Now, did you all finish step 1? Is there anybody pending? See, if you tell us, please, our mentors are available here. So if you have any doubt, if you are getting, run that cell. Okay, not just typing, please run that cell and make sure that the cell is, okay. Now, if you are working on Google Colab, you have to upload the CSV file into the Google Colab environment. Okay, so look at the projection there. So we'll show you how to. So just click on that and say upload, files upload. So browse your CSV file and then say OK. So you can see the breast cancer dataset uploaded onto the Google Colab environment. First, upload the dataset into the Google Colab environment. See, don't sit idly. If you are not able to do that, please raise your hands. We'll come there and tell you how to do that. Did you all upload the dataset into the Google Colab environment? See, you must be able to see your dataset there on the left like that. Error in what?
So I prefer please use Google Colab. If internet is not accessible here, if it is not, please use Jupyter.
Okay, so for which again you need internet. That is the reason you are getting errors, as sir told you. Okay, so if it is Google Colab, it is on cloud, so automatically we have all the installations done. Okay, yeah. So are you all able to see breast cancer on the left? Did you all upload? How many of you are still doing this? Please raise your hands.
Yeah. Everyone is able to see that screen, Google Colab. This screen, Google Colab screen. There is a file icon there. You see that madam is highlighting there. File icon. Please click on that so you will get that panel. Right? That's it.
Okay. Now in step 2, we'll try to load the data set. Okay. So we'll see how do we load the data set. Okay. Now we say pd dot read underscore CSV. We'll put that into a variable. Okay. Data is equal to, yeah. So we'll try to read the data set which is already available in the Google Colab environment. So we say pd dot read underscore CSV. Okay. Now inside that you have to give the path of the data set. Okay. So just go to the data set. Okay. So click on that. You will get an option copy path. Okay. So click on the data set. You have 3 dots followed by your data set. Click on that. You will get the option copy path. Okay. Copy path. Copy that path into the pd.read_csv file. Okay. If you are working on Jupyter, okay, you have to give the path where your data set is available inside your system. Okay. Okay. So I'll go to my location where my data set is available. Okay. And then I say okay. So if you are working on Jupyter, you have to give this path. If you are working on Google Colab, just copy the path and paste it. Okay. So if you are working on Jupyter, you can give raw string. Okay. You can just put R and then upload the data set. Okay. So did you all read the data set? Yes or no? Is there anybody else who is still doing? Okay, so we'll proceed. Listen to Listen to me now. So how many rows and how many columns are there in the data set? We have 100 rows and 14 columns, right? So out of these 14 columns, we have to pick one column as our output variable. Then you can again continue. Okay. Now I have 100 rows of data and I have 14 columns, right? So out of these 14 columns, 13 columns would be input variables and one column would be my output variable. So I have to define my input and output variables after I read my data set. Okay. So as you can see here, the variable names. Okay. As you can see the variable names, I have ID number, I have diagnosis, I have texture mean. Of course, we don't understand all this medical terminology, but we'll see what would be the output variable. Okay. So the diagnosis here is my output variable. Okay. So what can you see there in the diagnosis column? Two things, M and B. What is M and what is B? Malignant and benign. Okay. So what do you mean by malignant? It is cancerous. What is benign? Not cancerous or in the beginning stage or whatsoever it is. Okay. So this should be my output column. The other columns would be my inputs. Okay. So I have imported my libraries. I have loaded my data set. Now I'll define what are my input variables and what are my output variables. Okay. Let's start doing that. Take a next cell. Okay. Go for next cell and say so I'll now separate the data set into my input variables and output variables, which are called as dependent and independent. Okay. What is dependent and what is independent? Dependent is my output variable. Independent variables are nothing but my input variables. Okay. Step 3, I am defining my input and output variables. Okay. Let's see how do we do that. I say X as my input. X is equal to, say X is equal to data dot drop. I'll tell you what is this. Data dot drop the diagnosis column. See what am I doing? In the input variable, load the entire data set by removing diagnosis, because diagnosis is my output variable. Okay. X is equal to data dot drop diagnosis. Okay. So there are two important functions that we see here. Okay. One is the axis and second one is reshape. Okay. Now please listen to me. Why do we do this? Because if you don't understand this, you will not be able to get proper outputs for the next exercise. So all of you please listen to me. So what is X there? X is input, okay, where I want to take all the features except what? Diagnosis. So hence I am dropping that particular column. Okay. Now we take a module called axis or parameter called axis. If axis is 0, a particular row will be deleted. If axis is 1, a particular column would be deleted. All of you please make a note of this. What does axis is equal to 0 represent? A particular row is deleted. But what do I want to delete here? A column which is called as diagnosis. So hence I give axis is equal to 1 and then I print my values. Okay. Now when I talk about y variable, what is y variable? What is y variable? Output, which is nothing but that particular diagnosis column. Okay. Now when I remove diagnosis column from X and take it separately, it would be displayed as data frame with all row values. But I want that to be displayed as what? Column. Hence I reshape that. Okay. So all of us have used reshape function in our Python, right? So I want to convert my data frame from row axis to what? Column axis, because diagnosis is to be taken as what? A column for my y variable. Hence I reshape that. Did you all finish this? Did you all finish this step? Completed? Determine what is x and what is y. X is independent variable, y is dependent variable. Input and output. Yeah. If you remove that particular column from the data frame and when you load it into y, it would be appearing as row values. But I want it into one column. I am accessing my y as a column. Okay. So for that reason we do reshaping. Did you all complete this step? Is there anybody still doing this? Shall we proceed to the next step? Yes. Okay. Okay, we'll go with step 3. Look at this. For those who still have doubts on reshape, look at that. If I don't give reshape minus 1 comma 1, what happens is the y is read as list of values in one single row. Okay. But how is my data set available? In 100 rows with all different columns. So my output y variable should also be appearing as what? Column. Okay. So if you don't type reshape there, your y value would be appearing as 100 values as row. One single row with all array values. Okay. Now let's type reshape. Okay. Now this is how your reshape works. Okay. Now my y is displayed as what? One column with 100 values which will match with my x. Is reshape function clear, everybody? When you are dropping one particular column and then reading it again, it will give you list of values. Okay, but I want it as one column, for which we use reshape function. Okay, we'll go with next step. Okay. So far we have imported the libraries, we tried to read the data set and we have divided the data set into x and y, where x has input variables, all the features except one column, and y will have that particular output column which is diagnosis. Okay. Now we will do some pre-processing on this data set. Okay. So what is that pre-processing option that I am using here? I will explain you that. Okay. So we have already imported standard scalar, right? Okay. Now there are two important pre-processing steps that we do depending on the data set that we take. One is called normalization, second one is called standardization. For today we will use standardization. Your assignment would be check what is normalization and then when do we use normalization. Today for this data set we require standardization. I will explain you that by using standard scalar. Okay. Now listen to me very carefully. We have 14 columns in the data set, out of which we have removed one column called diagnosis and considering that as output column. The remaining 13 columns are your inputs, right? Yes or no? Okay. Now these 13 columns have different values which are there in the data set. For example, if one column may have values starting from 1 to 10, second column may have values starting from 1000 to 10,000, third column may have values starting from 0.1 to 0.9, depending upon that particular variable. Yes or no? Okay, let me give you some raw example. Let's say I want to calculate the price of the product based on the age. If suppose I want to buy a second hand car, okay, so I have two particular things which I am considering: the age of the car, the price of the car. Depending on this, I'll check if I want to buy the car or not. So what are the two inputs I am taking here? The age of the car and price of the car. So the age would be from 1 to 10 or 20 at max. Nobody will buy a car which is more than 20 years old. Okay. But when I go for the price column, the price may vary from 1 lakh to 10 lakhs. So I have difference in values in each feature. One feature is age, where the values are from 1 to 10 or 1 to 20. The second feature is what? The age, where the values are starting from 1 lakh or 10 lakhs to 20 lakhs or 30 lakhs. Okay. So when you try, see, machine learning is all about making machine understand your data and then work on it, right? So when machine sees this discrepancy in the data, it does not understand which is important variable. See, it may think the more the value, more important the variable may be, but that is not actually correct. So we have to standardize the values which are there in the features. We have to do what? Standardize the values which are there in the features. Okay. So what do you mean by mean and what do you mean by variance? What is standard deviation? What is mean? The average value. What do you mean by variance? Difference between one point. Okay. So what is standard deviation? We have this x minus mu by what is standard deviation? X minus mu by basic mathematics, man. What is mean, you know. What is variance and what is standard deviation? Okay, I'll show you that with example. This is a simple data that I am taking. Okay. So what is there in feature A? 5 values starting from 10 to 50. What is there in feature B? 5 values starting from 200 to 600. Okay. Now, for feature A, let me calculate mean. Mean is nothing but the average value. 10 plus 20 plus 30 plus 40 plus 50 by 5. Okay. So the mean here is 30 and the standard deviation here that I got is what? 15.81 for feature A. When you look into feature B, the mean is 400 and the standard deviation is what? 158. Okay. So there is so much difference between feature A mean and feature B mean. Okay. So how do I standardize this? Next step. Okay. So I'll apply the standard deviation. Okay. So how do I do x minus, what is that? X minus mean by total. Okay. So as you can see, for feature A, it is 1.27 for the first value. For feature B also it is 1.27. So did I standardize them? So what am I doing here? By applying mean and variance, I am trying to standardize the values both in feature A and feature B, such that all the features will have equal importance when we consider our data sets. Okay. So the machine will not have that feeling that this value is more or less, such that this should be given importance or not. All the values in the data set should have some equal importance, for which we will standardize the data set by using which function? Standard scalar function. Okay. So when we look into the breast cancer data set also, the remaining 13 features except diagnosis have different values. So when you standardize them, they will be of equal importance. Is that clear? So for that reason we use which function? Standard scalar, which is one part of pre-processing. That is the reason from sklearn.preprocessing we have imported the function what? Standard scalar. Now let's see how do we apply standard scalar into the code. Okay. Take the next code cell. Once you are done with loading x and y variables, please take the next cell and do the standardization. Scalar the data. Okay. So I am scalaring my, see, do I have to do this for y? Y is only output, which is M or B, only two categories. I have to do this only for x. So I write scalar is equal to standard scalar. I am using the function. I am calling that function and say x scaled. I am only doing scalar for x variable, that is input. So I say x scalar is equal to scalar dot fit transform. X scaled is equal to scalar dot fit underscore transform. So using standard scalar function, I am standardizing the data. Okay. Now once I am done with standardizing the data, I will go with train test split. What is train test split? Splitting the given data set into train data and test data. Okay. So the next step would be train test splitting the data. Okay. Split the data into training data and test data. So how many samples did I take in the data set? 100 rows, right? So I will divide these 100 rows into train data and test data. 80% train, 20% test, or 70% train, 30% test. Okay. So give x train, comma x test, comma y train, comma y test. Okay. Now when you stop here, I will explain you what is x train, what is x test, y train and y test. Okay. X train, x test, y train, y test is equal to use the function train test split that we have already imported, and we'll pass some parameters inside that. Okay. So we'll see what are the parameters we are passing inside the function train test split. So which data I am using for train test? I am not using direct x, I am using scaled x data. That is, after I perform standardization, I have used a variable called x scale. So I call that comma y comma test size is equal to 0.2, which means 20% of the data is to be taken for testing. The remaining 80% would be taken for training. Okay, if you want 30% test, give 0.3. Okay, I am also passing another parameter called random state. I will explain you what is this random state once you are done with executing this block. X train, x test, y test is equal to train underscore test underscore split of x and y, not normal x. I have to take standardized x. So x underscore scale, comma y, comma test size. You are supposed to give what? Test size, that is equal to 0.2, which means 20% of the data I am taking for testing, comma random seed is equal to 42. I will explain what is random seed, what is x train, y train, all that once you are done. Did you all finish this step? Okay, now listen to me. I am trying to divide these 100 columns into train data and test data. 80%, when I say test is 0.2, 20% is testing, 100%, remaining 80 are training. Now listen, x train is nothing but input x which is taken into the training data. Y train is nothing but output y which is taken for training. X test is nothing but input x which is used for testing. Y test is nothing but the output for the test. Okay, did you all understand? X train, y train, x test, y test. Are you all clear with this? Yes. Okay. I am splitting data of scaled of x and y, that is x scale and comma y, and then I am giving test size. Okay, now listen, what is this random seed? Okay, so random seed is basically used for reproducibility. Okay, that means if suppose I am running this particular code once, I have random values of 100 splitted into 80 and 20. But when I want to run this code again, I don't want different samples of 80 and 20. I don't want my samples to get changed. Okay, I want the same samples to be continued even if I run the code for 2 or 3 times. Are you getting my point? Please listen to me. If suppose there are 100 people here, I use these 80 people for training, these 20 people for testing. Next time when I run, I want these same 80 people for training, not different 80 people changing here and there, because everything gets disturbed. Because my accuracy may be changed or the model parameters would be changed. So when I am running the code n times for n epochs, I want the same split content to be available in training and testing to check the accuracy well. Okay, so for which we use this parameter called as what? Random state. Okay, 42 is just a number that they have given. There is no specific significance for that. Okay, so if you don't give random state, what will happen? When you run once, some data would be there in random train, some data would be there in test. When you run it for the second time, different samples out of those 100 would be available in train, different samples would be available in test. Is that clear? Did you all understand? Okay, so this is how we do train test splitting. This is next step. So what did we do so far? What was step 1? We have imported the libraries. Step 2, we load the data set. Step 3, we have divided the data into 2 things, x and y, where x is all the input features, where we have dropped the output variable and called that output variable into y column. Okay, after splitting the data into x and y, what did we do? Standardized the data, because different features in the data may have different values ranging. So for that we apply standardization and have standardized the data. After doing standardization, what did we do? We have split the data into 2 sections. One is train data, the second one is test data. Okay, we'll go with the next step. Now look at this. If you want to display, if you want to see the shape or how many samples are there in train and test, just type shape. Okay, so as you can see, 80, 13. What is 80, 13? X train. 80, there were 100 samples. So when I take 20% of training data, 80 would be rows, 13 would be columns. Okay, now when I see 20, 13, what is 20, 13? X test. 20 samples, 20%, 13 inputs. Okay, y is only 1. So y train would be 20, 1. Y test would be y test would be 80, 1. Y train, yeah, you got it. Okay, so X train, Y train, X test and Y test. So you can see the shape like this. Just for your reference, you need not do that in code. To make you understand what is X train, X test and Y test. Okay, we'll go with the next step. Okay, now we'll try to build a network. Okay, now we'll start with actual ANN. So far we have only did the basic steps, that is reading the data set, splitting the data set into X and Y, performing pre-processing and all that. Now we'll actually start building the network. So please look at this. First we have to initialize the parameters when we start building the network. Okay, so what is step 1 under building the network? We have to initialize the parameters. Okay, let's see how do we do that. Input underscore size is equal to x underscore train. I have to give my input size, hidden size, how many hidden layers I am taking, how many output neurons I am taking, what is the size of input and all that. I am just basically declaring my input layer, output layer and hidden layer. Okay. So let's start initializing the parameters to build a network. I first take input size, which is nothing but the size of X train. One layer. Input is only one layer, right? So 1. Okay. Next, hidden size is equal to 10. I am randomly taking hidden size. Hidden size is not number of hidden layers. Hidden size is the neurons in the hidden layer. I am taking only one hidden layer with 10 neurons. Okay, that is a random value. You can put 8, 20 and you can check. Okay. So I am initializing 3 parameters, that is I am taking only one input layer with which X train, okay, and then I am taking only one hidden layer with 10 neurons in it, and I am taking output size is equal to 1. Only one neuron in the output size. Why? Because I have only 2 classes saying whether it is B or M, benign or malignant. So I will take only one output. If it is 0, it is benign. If it is 1, it is malignant. So I am initializing these 3 parameters. Only one input layer with X-train data, one hidden layer with 10 neurons, and then one output layer. Did you all do this? One hidden layer with those features. Okay. See, when I give X-train dot shape, all the 13 variables would be taken. Okay. Did you all finish initializing the parameters and designing the network? Yes or no? Is there anybody still doing this, or should I proceed? Make it fast. At least we have to complete forward propagation today in the class. Once you have initialized the parameters, now we'll try to define a function to make some connections and build a network. Okay. So first initialize the function parameters, input size, hidden layer, output size, and after that we will define a function to initialize the weights. We will define a function to initialize weights. Okay. Now I need 2 weights here. Please listen to this point. Please listen to this and you can continue. I need 2 weights here, W1, W2. Why? W1 is nothing but connection between input layer to hidden layer adding weights. Whenever we add each layer, we have to add weights, right? So W1 is nothing but the weights that I am adding from input layer to hidden layer. W2 is from hidden layer to output layer. Please make a note of this point. I am taking only one hidden layer, right? So when you want to make connections between input layer to hidden layer, we add weights W1. Okay. So when you are making connections from hidden layer to output layer, we add weights W2. So hence I am having W1 and W2 being initialized. Similarly, I have my bias B1 and B2. Okay. I have to generate weights and biases here. As I am taking a simple neural network with only one input layer, one hidden layer and one output layer, I take 2 weights. W1 for making connection between input and hidden, W2 for making connections between hidden to output. What is W1? What is W2? Is input to hidden, W2 is hidden to output. Okay. Now I say np.random.seed of 42, that is randomly I want to generate the weights. Okay, and then say W1 is equal to np.random.randn with respect to input size and hidden size. Look at the parameters. What is W1 doing? Randomly assigning the weights from input layer to hidden layer. Okay, now look at that. I am using a variable called into 0.01. Okay, so I am adding a small learning rate here such that my weights would not be too big. Okay, I have to randomly change my weights such that I want to take a small weight. Randomly generated weights would be too high. So I want to shrink that into small weights. Okay, for that reason I multiply the randomly generated weights with a small value which is called as 0.01, because your network may take 10,000 times to do the process. So when I take bigger weights, the calculation would be tedious. So to obtain small randomly generated weight might be anything. So if I want to take a small weight, I multiply that randomly weight generated with 0.01. Simple for fast convergence. Okay, to avoid complexity and fast convergence, I go for multiplying that randomly generated weight with 0.01. Okay, so W1 is nothing but the random values which are generated between input and hidden size. I am multiplying that with small value for faster convergence to avoid complexity of taking larger weights. I want very small weights to be assigned. Hence I multiply the randomly generated weight with small value. Okay, now bias, for initial way we take bias to be 0. So I am simply using np.0 for generating biases. Okay, so I am taking two bias, B1 for hidden size, B2 for output layer. Bias is not a connection. Inputs are, weights are nothing but the connection between input to output. Hence the parameters are input size and hidden size. But bias is a value that I am generating for each layer. Okay, so for hidden size I take B1, for output size I take B2. So I am taking a function called initialize parameters and I am initializing W1, W2, B1, B2 for input layer, hidden layer and output layer. We have initialized the parameters and we have defined a function to read those parameters and assign weights and biases to that particular network. Did you all finish this? So I have built a network now. I didn't start forward propagation yet. I have just built a network. That is input size, input layer, hidden layer, output layer and connections to input, output and hidden with respect to what? Weights and biases. Did you all complete till this? Yes or no? What would be next step? What would be next step? Yes? Huh? What would be next step? I'll define activation functions in the beginning only because before forward propagation I'll define activation functions. Why? Because when I start with forward propagation, weights into W plus activation function should be there, right? So next step is we will define the activation functions. Okay. Now stop here and tell me which activation function do I use here? Sigmoid. Why? I have only one input layer. Okay. And I am going for what? Binary classification. Okay. So I'll use which activation function, guys? Sigmoid, which says whether the output is 0 or whether the output is 1. That is B or M. Okay. Benign or malignant for this data set. Okay. So we'll see how do we define the activation functions and wind up for the class for the day. Okay. Next session we'll see how do we go for forward propagation, loss calculation and backward propagation. Okay. Bias is initially zeros. Okay. So we will see how do we define the activation function now. Okay. So which activation function are we using? Sigmoid. So what is the formula for sigmoid? 1 by 1 plus e power minus x. Okay. So we'll define the activation function. So define sigmoid. Please complete this. Let's start working on defining the activation function such that we'll start working on those 3 steps which we have discussed. Define sigmoid function. Okay. So as you said, the sigmoid function is 1 by 1 plus e power minus x. See, all of you please listen to this. So I've already explained you the loss function or activation function formulas in the last session. Okay. So next class when we come and when we open tantric exercise, we will not explain you like this. Okay. You should know the formula for regression, you should know for the formula for classification or ReLU or TANH and you should be able to work on the activation functions by yourself. Is that clear? We will not explain you all the activation function formulas from the next session. Okay. So as this is the first session, we are doing it from scratch for you. Use NumPy and then define all the activation functions which are required for developing your own model from the next session. Okay. Why am I deriving the derivative of sigmoid? Because in the back propagation, I want to calculate my loss with respect to the weights, right? So that is the reason I am also defining another function which is called as what? Derivative of that particular sigmoid. Okay. So define basic sigmoid function and also derive derivative of the sigmoid function which we will be using in backward propagation. Okay. So don't get confused, we are using the derivative of the activation function for using it in the backward propagation process. Did you all finish this? Okay. So we'll wind the class today till here. So what did we do so far in the class? What was step 1? I want response from everybody. What was step 1? We have imported the libraries. So what are the 4 things that we have imported? NumPy for what? For calculations, numerical operations. Pandas for reading the data set. Third one was from sklearn we have imported pre-processing module which is standard scalar. I have explained you why do we have to standardize the data, and I have given you one assignment question. What was that? Sometimes we do standardization like what I explained you. The second other pre-processing step is normalization. So you have to find out on what conditions we use normalization. What is normalization? When do we do normalization? That is your assignment. Okay. And what was fourth importing? From sklearn model selection we divide the data into train and test, for which we have used train test. This was step 1. What was step 2? We have load the data set using pd.read_csv module. Okay. After we load the data set, what do? We divide the data set into x and y. Okay. What would be x? All the variables except one, which would be the output. So in our data set, diagnosis was the column which I have to take into y variable. Hence I have dropped that from x and that I have taken into y variable. Okay. So after doing x and y, what do? Standardize the data. Okay. So in order to normalize the values in the features, we go for standardization. Okay. After standardization, splitting the data into train and test. So how many samples did we have in the data set? 100. You have to know. When you work on data set, you should know how many rows are there and how many columns are there. Okay. So we had 100 samples. When divided into 80% train, 20% test, we have 20% test data and 80 values for training. After train test splitting, what did we do? We started building the network. So what was step 1 in building the network? Initialize the parameters. So how many parameters did we initialize? 3. Input size, hidden size, output size. See, initialize is nothing but building the network. Input layer, hidden layer, output layer. So how many input layers? Only one, which is nothing but shape of the X train. That is all 13 features. What would be, how many hidden layers? Only one with 10 neurons. How many output layers? Only one output layer with only one neuron, which says either M or B. After we initialize, what do? We define a function for initializing weights and biases. So when you initialize weights and biases, the connection between the layers would happen. Okay, that is input layer would be connected to hidden through W1, add B1. Hidden layer to output layer connection will happen through W2 by adding B2. What is W1? Random weights that are assigned between which layers? Input and hidden. What is W2? Weights that are randomly assigned between hidden and output. What is B1? Bias for the hidden layer. What is B2? Bias for the output layer. Okay. So which activation function did we use here? Sigmoid, because it is a binary classification task. Next assignment might be something else and you have to change your different activation functions, and I will not tell you which activation function to be used because I already told you in the last session. Okay. So after we define the activation function, what is the need for finding the derivative of the activation function? Because when we go for backward propagation, we have to calculate the derivative of loss with respect to weights. So hence we also calculate derivative of the what? Sigmoid function. Okay. So what would be next step which we are going to do on Friday? Forward propagation, loss calculation, backward propagation, and then repeat it till you get good accuracy. So in the next session we would complete building what? ANN model from scratch on breast cancer data set. Is that clear, everybody? So looking forward for the next class. I'll share you the notebook till this particular point so that you can sit and refer if you have any doubts and any errors. Okay, we'll add comments explaining each step. For those who are absent, you can learn it from the beginning. Is that clear?